Good afternoon, everybody. Sir, my voice is audible?
Yes, very.
Yes, sir, yes, sir.
Very. Please continue. Good afternoon. Please continue.
Myself, Patan Raj. I am working in WRI NDT for the past 2 years. Now we are going to see the case study of construction of new Pumban bridge. In the Pumban bridge, WRI role is establishing welding procedures and qualifying the welders, and welding consumable evaluation, periodic witnessing of welding activities, review and validation of NDT procedures, review of PAUT data and reports at WRI to ensure its precision. The NDT shall be carried out internally by the fabricators in-house NDT team. PAUT data will be interpreted and sent to WRI by that fabricator PAUT operator through mail or Google Drive. Once all repair is cleared internally, the witness call will be provided to WRI. After getting the call from that fabricator, we are going to visit the site, review the NDT reports for weld inspection on a particular day. 100% the weld length should be visual inspection at a site. Witnessing of computer RT joints at site. In addition to witnessing the penetrant test of 30% weld length at site, and also 30% weld length for PAUT inspection at site. These are all the role at NDT inspection. And the inspection and testing. First 100% inspection done by the contractor, employed agency. They are doing the visual inspection, penetrant testing and PAUT. PAUT is phased array ultrasonic testing. For WRI inspection, 100% visual testing and 30% weld length randomly we are checking the penetrant test and PAUT. These are all some photos of liquid penetrant inspection during we done at the time. Implementation of PAUT in Pumban bridge. First we should prepare that draft procedure as per design requirement. Review of the weld configuration available in the lift span. Lift span means that the center portion of the bridge. We prepare the scan plan for combination of different plate thickness and validation block preparation. Thereafter validation trials and fine tuning the scan plan. Final revision of the scan plan and procedures. Thereafter approval of procedures and implementation for production of welds. Why we introduce the phased array instead of UT? The UT is a conventional one. In UT, we have some limitations in this method, because in UT that manual scan we should cover the full coverage and very difficult to defect the defect characterization and need highly skilled manpower. The inspector have to rely on the operator. So instead of that we can go to PAUT. In PAUT some of the advantage, the technology with rapid inspection and image capability, the capability of steering, sweeping, focusing of the beam. The electronic scanning permit the rapid coverage, the beam focusing to orient perpendicular to the defect. So that only we are introducing the phased array. That the phased array is nothing but our medical ultrasound. But the industrial ultrasonic testing, that frequency we are using is 2.25 MHz to 10 MHz. Why phased array is used? The triggering array of crystal with or without phase difference to the generate the ultrasonic beam of required characteristics like this. This is the resultant waveform, because in PAUT probe having so many crystals in a single probe. Each and every single crystal create the ultrasonic wave. So all the waveforms are accumulated. Thereafter it will give the resultant wavefront like this. In smaller probe giving the wider beam spread compared to the conventional UT probe. Conventional UT probe is very big size, so the beam spread is very less. In PAUT the probe size is very minimum, so the beam spread is more, so we can cover the more weld area. This is the conventional UT probes. this is single probe. In PAUT, this is the probe. In the probe, so many crystals are arranged in some manners. This is the PAUT probe. These are all the crystals. This is damping material. This is probe casing, cable. This piezoelectric material is made up of piezo composite. Why PAUT? It is having high speed electronic scanning without moving the probe and the improved inspection capability through software control of beam characteristics. Inspection with multiple angles. In conventional UT, we should use in any one probe. If the probe is having 45-degree means you should scan in 45-degree alone. But in PAUT, in single probe, we can generate 45 to 70 degrees. So multiple angles we can create. So we can get the image any orientation. The defect in any orientation we can get the clear signals. So that only we are going to the PAUT. The advantage of PAUT: beam steering, beam focusing, and electronic scanning. Beam steering is nothing but the capability to modify the refracted angle of the beam by giving time delay from one side of the array towards other side. For example, in one probe having 7 crystal means first we can trigger the first element. So after some delay we can trigger the second element. Like that we can give the element one by one with the some delay. So we can get the beam front like this. This is beam steering. Beam focusing. Beam focusing is a technique where the ultrasound beam is focused on a desired point. In conventional UT, we cannot get this much of accuracy. The outermost crystal are triggered first. The delay is applied towards the inner crystal. We get the beam like this. First, the outermost crystals are triggered. After some time delay, one by one, we trigger the crystal. We can get the focus in this point. This is possible in PAUT. It is not possible in conventional UT. And electronic scanning. Electronic scanning is nothing but same delay law applied to different set of element to produce same angle in job. Like this. We can trigger some set of elements with some time delay to the next set. This is the electronic scanning. During electronic scanning, we cannot move the probe. Automatically the probe cover the entire weld area. Like this, we can generate the beam. That beam will cover the entire weld area from top to your root region. In Pumban bridge, we have used so many thickness of plates from 12 mm to 40 mm. For that PAUT inspection, we should create the validation blocks. 16 mm block, 32 mm block, 40 mm block. So every block we should validate before going to scan. This is the validation block we prepared before inspection of the Pumban bridge. The first defect, this is the top view of the validation block. The first defect N1 is side wall lack of fusion. This is artificial, we made it. The validation block is artificially we made it. This is side wall lack of fusion. The second one is perpendicular to your weld. This is cap toe fusion defect. This N6 also cap toe fusion defect. The N3 is cap center line defect. Sorry, N4 is cap center line defect. Like this, we create the so many defects in the validation block. According to our scan plan, all the defects should be detected by our scan plan. These are all the defects. This is the PAUT machine, that screenshot. In that machine, this is the V, this V shape having the weld area. In that weld, this is the defect identification. This defect is side wall lack of fusion at depth 10 mm from your toe region. This is a defect. This is A scan, C scan and S scan. This is data from the 16 mm validation block. This is toe region defect at the top of the your weld area. You can get the signal like this. In A scan you can get the signal like this. This is the defect signal. The amplitude is 100.8%. The depth is 0.5 mm from toe region. And this one also in toe region the defect will be here at the depth from top to 0.63 mm. The amplitude is 91 mm. This is also toe region defect. These are all the defects during validation block. This is the after made the weld. Before scanning the defect will be there. After they made it a repair, then only he can get the screen like this. After defect clearing, we can get the signal like this. Now no defect will be there. We can pass that weld area. Thank you all.